Within all this, we just need to take account of the role, particularly of a key enzyme, which is lactate dehydrogenase. Now, lactate dehydrogenase is actually comes in two forms. LDH1 is associated with the formation of lactate, and LDH2 favours the conversion of lactate to pyruvate. Now, this is really important. Although we can talk about lactate dehydrogenase as being a fundamental component within lactate production, there are actually these two types. And what we know is that LDH activity is lower in type 1 fibres compared to type 2, but the contribution from LDH2 is higher in type 1 than in type 2 fibres. Now, what we know is actually these have two distinct names. We have what is called muscle-specific and heart-specific LDH, and it's pretty obvious which is which. Muscle-specific is generally referred to as LDH1. Heart-specific is generally referred to as LDH2. It's not that they are just associated with the muscle and the heart, it's just that there is a predominance of LDH2 in the heart, there's a predominance of LDH1 in skeletal muscle. Both exist. Remember, the heart isn't going to really, in a healthy condition, produce lactate. Okay, you don't want lactate being produced in the heart. So the heart actually can be a consumer of lactate, so it's going to be rich in LDH2. Whereas in our skeletal muscles, we understand that there's more LDH activity in type 2, but it's much more, LDH2 is much higher in type 1 than type 2. Why? Type 1 fibres, remember, they're MCT1 rich, which means they're good for disappearance because they want to convert lactate back to pyruvate. They're mitochondrial rich. Therefore, they're going to be associated with the conversion of lactate back to pyruvate, LDH2. And again, we understand that lactate dehydrogenase increases, the concentration increases in response to endurance-based exercise. And so the simple answer is yes. Could there be an association between the training states of lactate dehydrogenase levels and the use of lactate as a mitochondrial fuel? Yes, absolutely. So if you expose somebody to an endurance training program, we know that there is an increase in lactate dehydrogenase. We know, as we saw previously, there is a decrease in lactate, blood lactate concentration, primarily because you've got a decrease in the rate of appearance, but coupled with that, the lactate that is being produced and enters the circulation can be taken up at the inactive fibres, because they're going, ideally the slow twitching active fibres that are MCT1 rich, they're mitochondrial density rich, and because endurance training increases lactate dehydrogenase, then the lactate is converted nicely back to pyruvate.